Determine the equation of a line passing through the point 2, 3 and it makes an intercept of length 3 units between the lines y plus 2x equals to 2 and y plus 2x equals to 5. Okay, let us begin. First, what we'll do, we'll try to understand the problem graphically. Now clearly these two lines y plus 2x equals to 2 and the line y plus 2x equals to 5, these two lines are going to be parallel to each other. So here we have the two parallel lines y plus 2x equals to 2 and y plus 2x equals to 5. We have another line, let's call it the line L, and we need to determine the equation of this line as it passes through the point A with coordinates 2, 3 and it makes an intercept of 3 units between the two lines. Now we can immediately find out the equation of the line L passing through the point A, and supposing that it makes an angle of theta with the positive direction of x-axis. And here we can have the equation of the line L passing through the point A and making an angle of theta with the positive x-axis. Then in that case we have minus 2. We take the difference of the x-coordinate divided by cosine of the angle theta. That's going to be equals to y minus 3 divided by sine of the angle theta. So this is going to be the equation of the line. Now depending upon the value of theta, we can find out the equation of the line. So our task will be to find out the value of cosine theta as well as sine theta. Now we have the line L which intersects the line y plus 2x equals to 2. Let's say it intersects it at the point B, and it intersects the point, the other line y equals to 2x plus equals to 5, let's say at the point C. Now we are assuming that the distance between point A and point B, that's r, then we can determine the equation of the line L in terms of the coordinates of A and B. So here we can have x minus 2 divided by cosine of angle theta equals to y minus 3 divided by cosine of angle theta, and this is going to be equals to r, where r is the distance between the points A and the point B. We have already assumed that. So what we can do here, we can find out x and y. So x minus 2 is going to be equals to r cosine theta, and y minus 3, that is going to be equals to r sine theta. So I made a mistake here. This is not cosine theta, this is sine of the angle theta. So x comes out to be equals to 2 plus r cosine of the angle theta, and y comes out to be equals to 3 plus r sine theta. So actually what we have done here is we have now found out the coordinates of the point B in the parametric form. So the coordinates of point B in the parametric form will be 2 plus r cosine of theta, and the y coordinate will be 3 plus r sine of angle theta. Okay, now similarly what we can do, we can find out the coordinates of point C. Now point C will be such that it is going to be at a distance of r plus 3 from the point A. So point C is at the distance of r plus 3 from A. So here we get x minus 2 divided by cosine of the angle theta equals to y minus 3 divided by sine of the angle theta, and that is going to be equals to r plus 3, which means that we have x given by 2 plus r plus 3 times cosine of angle theta, and y is going to be equals to 3 added to r plus 3 times sine of angle theta. So now we have expressed the coordinates of B. So express the coordinates of B in the parametric form as we have 2 plus r plus 3 times cosine of the angle theta. This is going to be the x coordinate. The y coordinate will be 3 plus r plus 3 times sine of the angle theta. Now, as we can observe here that the point B is going to lie on the line y plus 2x equals to 2. So it must satisfy the equation of that line. So here we'll see that point B lie on the line. It lies on the line y plus 2x equals to 2. So that means it must satisfy the equation of this line. So we take the y, in place of y, we replace it with the y coordinate of point B. So that gives us 3 plus r sine theta. Added to, next we have 2x. So in place of x we have 2 plus r cosine of the angle theta, and that's going to be equals to 2. So we now have 3 plus r sine theta added to 4 times 2r cosine of the angle theta, that's equals to 2. Fine. So we have, if we take r as the common factor, so we now have sine of angle theta plus 2 times cosine of angle theta. So that's going to be equals to, we have 4 plus 3, that's 7. So 2 minus 7, that's going to be negative 5. We have r equivalent to negative 5 divided by sine of the angle theta added to 2 times cosine of the angle theta. We'll keep this aside for the time being. Similarly, we can say that C lies on the line y plus 2x equals to 5. So we have the point C lie on the line to y plus 2x equals to 5. So what we'll do, in place of y, we replace it with 3 plus r plus 3 times sine of the angle theta added to 2 times x. So x is going to become 2 plus r plus 3 times cosine of the angle theta, and that is going to be equals to 5. So let's find out r from here. So we have 3 added to r times sine theta plus 3 times sine of angle theta added to 4 plus 2 times r cosine of angle theta plus 6 times cosine of angle theta, that is going to be equals to 5. Furthermore, we have, so we can take r as the common factor from these two terms. So r is going to get multiplied to sine theta plus 2 times cosine of angle theta. And then we are left with, so we have 3 sine theta plus 6 cosine of angle theta, that is going to be equals to, so 4 plus 3, that's 7, 5 minus 7, that's going to be negative 2. Okay, now previously we already obtained that r times sine of angle theta plus 2 times cosine of theta, that's negative 5. So that meant this entire expression can be replaced with negative 5. So we have negative 5 added to 3 times sine of angle theta plus 6 times cosine of angle theta, that will be equals to negative 2. Okay, so let's further simplify. Now what we have here is 6 times cosine of angle theta, so that's going to be equals to 3 minus 3 times sine of angle theta. Let's do one thing. So let's take 3 as the common factor from each of the two, from both of the sides. We'll be left with 2 times cosine of the angle theta. So that becomes equals to 1 minus sine of the angle theta. Now what we'll do, we're going to square both sides. So squaring gives us 4 times cosine squared theta on the left hand side, and on the right hand side we have 1 minus 2 times sine of the angle theta added to sine squared theta. Now we know we have a standard identity, sine squared theta added to cosine squared theta, that's equals to positive 1. So here what we can do, in place of cosine squared theta, we can replace it with 1 minus sine squared theta. So that means on the left hand side we have 4 multiplied to cosine squared theta, we should get 4 minus 4 times sine squared theta. That's going to be equals to 1 minus 2 times sine of the angle theta added to sine squared theta. Fine. So what we'll do, we're going to combine all the terms and write it on one side, like we get 5 times sine squared theta minus 2 times sine of the angle theta minus 3 equals to 0. So we can factorize this quadratic equation. This is a quadratic equation in sine theta. So we are going to get sine theta minus 1 multiplied to 5 sine theta plus 3. That's going to be equals to 0. Okay, so we get, when we equate them, we get two values of sine theta. We get sine theta equals to 1, or we get 5 sine theta plus 3 equals to 0. So solving this gives us sine theta equals to negative 3 over 5. Now what we need is the corresponding cosine value as well. So when sine theta equals to 1, so we are, let's note it down, when sine theta equals to 1, then the corresponding cosine theta, so we can find out cosine theta by taking the help of this formula, since cosine theta equals to the square root of 1 minus sine squared theta. We're considering the positive value here. So cosine theta, that's going to be equals to 0. And when we have sine theta equals to negative 3 over 5, then the corresponding cosine value comes out to be positive 4 over 5. So now that we have the sine and the cosine value, let's go back to our original equation. So we considered initially the equation to be given by x minus 2 over cosine theta equals to y minus 3 over sine theta. We're going to use this equation. So we have x minus 2 divided by cosine of the angle theta, that is equals to y minus 3 divided by sine of the angle theta. So we'll use the first set of value when sine theta equals to 1 and cosine theta equals to 0. We have x minus 2 divided by 0 equals to y minus 3 divided by 1. So let's cross multiply. So cross multiply gives us x minus 2 equals to 0. So this is going to be one equation, x minus 2 equals to 0. And the other possibility is, if we consider we have x minus 2 over cosine theta to be 4 over 5. And then we have y minus 3 over sine theta. So sine theta is negative 3 over 5. So in that case, we are going to get negative 3x plus 6. That's going to be equals to 4 times y minus 12. So we get 3x plus 4y equals to 18. So that is going to be the other possibility. This is going to be the other equation of the line. Right. So these are the two final equations.